we're going to start going over the next section today while the other group takes their quiz, just so that when we do get together, we can kind of hop right into the very much new stuff to you. A lot of this is stuff that's kind of been hit on or that we've kind of already talked about. So 5.4, we're going to talk about more strategies for taking antiderivatives. So like it says, finding derivatives is relatively easier than finding antiderivatives symbolically. This section, we're going to take time to on the process of finding antiderivatives only. So we're only talking antiderivatives here. So far in our antiderivative conversation, we have done what's called definite integrals. And definite meaning they have a specific start and stop. You have oftentimes numbers for A and B. We did do some that had, like an X in there, and you did get a function answer. But you had something on the integrand, that's what the symbol's called, on the top and the bottom. Okay, so what we're going to look at for the next couple days actually is something called an indefinite integral. Okay. So that is one where the limit of integrations are unknown. This notation denotes that we just denotes not just one function, but we are going to get what's called families of functions. And so here is that indefinite integral. Okay, you've got your integral symbol. There's no numbers or anything, letters, variables, equations on your integrand symbol. And then you still need, the dx at the end. Your variables still need to match for your independent variables with that. So here would be an example. If you have the integral of cosine of x dx, we will get sine of x. And then here is where this whole idea of you get a family comes into play, and that's going to be your plus c. So plus c is going to be back in full force when you take a quiz. You might want to have somebody in your class stand up and say, hey, don't forget plus c, because we're going to be using that quite a bit this week, and then continuing in as we keep talking about integrals. So the difference really again is that there's not those numbers. Remember when you had an a and a b, those c's, if you think antiderivative should have had a plus c, they would have subtracted off, because if you did, f of x minus f of 1, this had a plus c minus this one had a plus c. And so all those c's canceled. And really when we put numbers there, it found that c value in terms of when we talked about like area functions, it found that c value. So now that we take all those bounds, the upper bound and lower bound away, now we need that plus c to come back to us. Okay, so in your textbook, page 333 has a whole bunch, like a huge list of all those antiderivatives. You may have many of these written down, especially if you had the page where you were kind of keeping track of all your derivatives and antiderivatives. The one that I do want to point out that we don't put this in when we talk about what's the derivative of natural log is that if I'm taking an antiderivative of 1 over x, your antiderivative is really the natural log absolute value of x and then plus c. And so just to kind of analyze and help you remember how this happens, so if you have 1 over x, it's really x to the negative first. And so when you like, oh, it's a power, when you go to up your power over your power, you notice that you get to divide by 0. So this is where you should have some kind of like red flag, something, that's my flag. Something's going wrong. What's wrong here? And so this is the special power rule one where you can't do it that way. It really is this natural log. And then you can't take the natural log of negative numbers. So that's why that absolute value is there, which is what this statement here says. So the absolute value is important because the domain of natural log, you have to use positive numbers. Okay, so if you need to write some of those down, hit pause, write them all down for that. And the last thing we want to review, and we talked about it a little bit last week when we were, talking about which type of integral definition do we use? Do we draw a picture and do area? Do we do an antiderivative? One thing that was discussed in there was this whole idea of algebraically simplifying. Not everything is going to be the strategy that we teach you later this week. There are going to be some that are you just have to simplify algebraically. Also we talked about that there's no quotient rule, there's no product rule, there's no chain rule for integrals. We're going to learn a whole new strategy starting this week of how to do those. But like in this case, because you're dividing by x, I can just divide both pieces by x. And that works because you just have a one term, a monomial in your denominator. If there was stuff adding and subtracting to x, then you have to be very careful. Sometimes you can't split then. So this would be the integral of 3 over x. I'm going to show my work here. So over x dx. Okay, so this would simplify then. So really, just for the sake of showing you this first one, and you'll get the hang of this, but this is really 3 times 1 over x, and then that's really just x dx. Okay, when we integrate, and there's adding, we can integrate each piece separately. So that first piece, the 3 is a constant, so I don't do any antiderivative function or anything with that. 1 over x is what we just talked about, is the absolute value in your natural log. Plus, and then x, we'll go x squared over 2. And then here's my plus c. So reminder, when there was numbers, we would put that evaluate bar from here to here. We're not going to have that because these are, again, these families. I don't have any numbers on my integral symbol, so this would just be your final answer. Okay. So I know this was kind of a short little video, but it's something, like I said, to get us started. So then tomorrow we can hop right into what are we doing and what are some other ways to simplify or to take an integral when I can't just simplify into some power rules or some of these other integral or antiderivative integral rules that are on page 333. So again, make sure you have these written down or have access to them so that when we get started, you have something to reference. Thanks for watching, and we will, like I said, continue this week.